Okay, now this is the data part for part 1 of the glass lab. So as I said before, we are on page 17, right? We are doing this top part right here. We are doing this part, which is the description prior to breaking. Prior to breaking. So let's look at this prior to breaking. We're actually going to start off with windshield glass. Actually, I don't want to mess you up. So let me grab a piece of my sharp flat glass. All right. So this is flat glass, window pane glass. Now, if we look at this, it's pretty clear. There isn't very much of a tint to it. It looks like a normal glass. The edges are kind of sharp. And I don't know if you can hear that sound. You can hear an echo, a vibration in it. So that's pretty much the type of glass that we have that you normally see. You can see through it. There's no real tint to it. And like I said, you have to be really careful handling it. This side is sharp. You could easily slice your finger. And you're probably sitting there, if you're like me, like this is a challenge for me. It can be really klutzy. So I have to be very careful with how I handle it. Okay, so that is flat glass. You can always pause and rewind if you want to get your description better. This is our tempered glass. Tempered glass goes through a process called tempering. So they heat and cool, heat and cool, heat and cool. And they temper the glass just like you would temper steel. So very similar in the sense that it has the same kind of feel, background feel. It's not as clean. You might say, oh, there's all that stuff on it. That's from the bubble wrap that I just undid, because this, if you hit it the wrong way, just shatters into a million pieces. If I tap it just right on a corner, it just shatters into a million pieces. This is the type of glass that is in the side windows of your car. The side windows, not your windshield, the side windows. It's tempered glass. Right? It shatters into a lot of pieces that aren't very sharp, and you will see that when I break it. Because if you're involved in an accident, they don't want flat glass just impaling you. So we have what's called tempered glass. There really isn't anything, different that much in feel. Now this is a different size glass, but it does have a different sound when I ping it. It sounds denser. It's a higher pitch on the ping. Trying to think of anything else you could put there for description. The tempered glass comes in a rectangular shape, which is how they formulate it and make it. They can't cut it. If they cut it, it shatters. My friend who owns the glass shop, who's given us windshield glass, he tried for me when a car would come in broken and he had to replace a tempered glass. If there was some still left, he tried to salvage it, but he said every time you try to, cut it, it'll just break into a million pieces. Okay, so this is tempered glass. The next type of glass you have prior to break is Pyrex glass. Now we're going to use our beaker, and it's graduated. It has a different feel to it. This is a little bit thicker on the way it's bent. It's shaped. You can pour any glass into a shape. You can blow glass into shapes. So the shape doesn't so much dictate its properties, it's how it's chemically made. It's got an additive in the glass that sits there between the glass molecules to give it different properties. You can see this one does have a little crack in the bottom, so we can't use it for chemistry anymore, but it's perfectly great for this lab for breaking. If this did not have a crack, it's very smooth. There's no rough edges to it. And it's part of how it was manufactured, because it's used as a device, holding like a cup in chemistry. Where did I put my crystal? It's here. All right, I will get the crystal in a second. This is windshield glass. Windshield is what we call laminated glass. If you look at the edge of it, there is a piece of plastic in between two pieces of glass. It is tinted, right? When you look at it, I don't know if you can tell. Let's see if we can tell looking down. Okay, the background is actually white, but if you look through the glass, you can see it has a tint to it, a real strong tint compared to the other things. Very reflective. And because of the way it was cut for me, you can take windshield glass and grind it so it's very smooth and it's not going to cut you. Okay, so that's the windshield glass. Now, the crystal, okay, so here's the lead crystal. So you have to go back up a line in your data. This is actually Irish lead crystal, comes from Ireland, shipped in, aka Amazon. Very heavy. It has lead in it, and if you look at your periodic table, lead interdispersed between all the little glass molecules. And the glass molecules basically is a combination of sand and lime, sort of. So this has lead interspersed in it, so it's heavy. And you can feel it when you go to grab it. It weighs more. It weighs more than if you have a regular glass in your hand of the same shape. Right? Lead was considered to be expensive metal. So if you had lead crystal, you were fairly wealthy. And I still remember when I was getting married, it was a big deal that you went and registered for crystal. I didn't want crystal. I registered for a set of glasses I really liked, and they're just regular glasses. But I did register for a lead crystal lead vase made by this company called Oriflor, which is a Swedish company. A lot of people have heard of other crystal companies that are really like famous, and some people have not heard of Oriflor. Oriflor makes gorgeous colored crystal. Very expensive though. I didn't get my vase. Nobody bought me my vase. I had a friend go buy a Waterford crystal vase, very classic. It's just not me. I still use it because it's a very close friend of mine. So I really wanted to say, why didn't you go buy me my Oriflor vase? Okay, so that's pre-break. I'm going to break them for you. So I'm going to move them over to a different area, and we're going to break it and shatter it. Now, when I break it, my goggles on, we're going to put them in plastic bags. So I'm going to move this. Hopefully you can still hear, because the dock where I have the mic has to be a little bit away from this. I can't move it. It's attached to location. A lot of paraphernalia with the glass lab, so please bear with me because I have to keep going and getting more supplies and coming back to break things with you. Yes, hammer. All right. So I'm actually going to break some of the other things prior to flat glass. Flat glass will be the last thing that I break, guys. So I am going to take the Pyrex and I'm going to smash that. So here's the Pyrex. I'm going to put it into a baggie, and then I'm going to double bag it and get the air out of it. When you have air in it, it just makes it hard, and then sometimes the glass will then pop the bag. I'm going to use some styrofoam board to protect my tabletop, because if you hit it hard enough, that force will actually make dents in the tabletop, even though this is a special lab tabletop. Okay. These. So I'm just gonna smash this. You guys ready? And there we go. Now I'm gonna hit it again because there's really big pieces in here. Well, actually, I'll show you that. See what I mean? That made that good. If I had it on the tabletop, I'd have all these scratches. Now you can see, I just hit it on one side. So this has a very large piece where it broke, where it was stressed. There's another second large piece. I'm going to cover this back up. I'm going to cut it into smaller pieces so I can use it later. I'm going to have to break it even more. So, you can see there's an edge to it, and the edge has some ripple effect in it. So we're going to look at that more on flat glass than Pyrex because the addition of the stuff on the Pyrex can cause issues when looking at that edge. The edges are sharp. Some pieces are big. Some pieces are small. And for instance, this is a smaller piece and you can see an additional crack running through it. Okay, so it does shatter, but some of the pieces are large. I have a collection of shattered Pyrex pieces right here. So you can see, if it's a beaker, it kind of holds the shape of the bottom. You can still see it's really hard to get it to crack along where the bottom of the beaker meets the top. This is just a much larger piece. So Pyrex, even though it breaks, has a tendency to break into larger pieces. When I go to do other parts of the lab, I have to break it into smaller pieces than this because I need the smaller pieces. We need the smaller pieces. Okay. The next one I'm going to break is going to be the tempered. And the reason why I'm breaking the flat glass last has to do with the construction of the lab. In the lab, you want to do the one hit break for the flat glass. So we're going to save and do it all at once. We're going to describe the break afterwards. I hate when the masking tape does this. This is what happens here in the science wing because there's no real environmental controls. They say it's controlled. It's not. I'm still working with that. Now they totally shut off my heat. So when I'm in on the weekend, it's like 60 degrees in the room, which isn't bad. And I'd rather have that for the chemicals than the 80 that it was. Found out we had radiant floor heating and they never shut it off and it was at 100. But instead of turning it down, now they just completely shut it off. Okay, so you might say, what am I doing? I'm following the instructions of the lab just to help out in the shattering of this. I am taping it with masking tape on all 4 edges. I know you're probably like, okay, this is boring. Well, you can fast forward until the point that I break it, but because of just the fact that I don't want to keep walking back and forth to the controls to pause it, you get to see me tape it. Don't worry, the other one I already have taped, and I already have it ready to go in the baggie. So you don't have to listen to me tape it. Some of you are probably going, oh, that sounds, ugh. Okay, now I'm going to put this back in a baggie so that when it cracks and breaks, we have containment. And I double back it. This is what we call a high consumable lab. We go through lots of baggies, lots of material. This year I'm only going to go through one of these. Usually every year we go through at least 3. 1 for each class. All right, so here it is, all set and ready to go. I'm just going to try to whack it along the side right here, right at this critical juncture. Not as easy as it sounds, believe it or not, because you got to be coordinated. So let's see if I can be coordinated. Nope. I hate to do this stuff. Come on. The other part is you have to have give. If there's no give, it won't break. Try it again. Trying to give it some give. There we go, finally. Hopefully you saw that. If you notice, well, I should really take out all my frustrations with this. Look at the pattern. It almost looks like Jack Frost on your windows. Okay, it's all like multiple breaks. And if I were to push on this, and I just did with my fingers, see how it just cascades out. So if we look at the little pieces now, I'm just going to try to be careful because even though it's made to be safety, it's still glass and it can have some sharper edges to it. It's really tiny pieces and they just fall apart. Like you put a little pressure and wherever it's broken, it just comes apart. If I were to put pressure on this part, where you see all the little lines, it just falls apart. Okay, and these are not as sharp and pointed as you see when we go to do the flat glass. They get really sharp. They're like a dangerous weapon. You can break a piece of flat glass and as long as you don't mind cutting your own hand, you can use it to hurt someone. I have to tell you this story. Started working here in New Hartford. We had to clean up the old chemistry lab. It was a shambles. Full of old chemicals, a lot of stuff. And we used a scalpel to help scrape off things that were stuck. And you guys can see this is like all like loose pebbles. So the insurance person comes in every fall and inspects and then writes up things and says, okay, you have to take care of this. So we had a box and the box had sharps on it for waste. So we go to get called in and we're told we couldn't throw out the scalpel because the student could reach in, grab the scalpel and stab somebody with it. And I turned to the gentleman and I said, so what are you going to say to the biology teachers when they do dissections with scalpels? They have to stop using scalpels. I still got written up that there was a sharp that had a scalpel in it. It was ridiculous. But my friends, that's New Hartford. Okay. So this is windshield glass, right? This is the one that's got the layer in between. Notice the difference too. The one that I just broke was not windshield glass. That was tempered glass. Remember, tempered glass is the one that's in the side windows in your car. This is in the front of your car. You guys try to keep that straight because there's questions about glass and how it breaks at the end of this unit and at the end of this lab. And I can't tell you how many people confuse windshield glass and tempered glass. So try to get it straight. Get an air bubble. It's going to pop when I hit it. Because of the nature of this glass, I'm not going to use any special method to hit this. I'm just going to whack it. And I'm going to hope that it has some break to it. Okay, now you may want to, plug your ears because it will be loud. Now, the way I whacked it, if I look at this, and I'll try to take this out, there are little small shards because of the way I whacked it, because I whacked it more towards the edge, that fall apart. See, there's little tiny ones down there. But if I bend this, it's all still together. I can't peel it apart. It doesn't fall apart. And I'm not going to take it out of the plastic because then all the little pieces will go everywhere. But it's still all like completely intact because of that piece of plastic that's there. So when you make your observations, make sure you say, that little thin piece of plastic holds the glass, even though it's broken, still kind of holds it in place. It's not able to go and fly anywhere. All right, so the last one I'm actually going to break, but I'm going to show you this other one first. The lead glass. Let's find it. Now, when you break the crystal, it doesn't break very well. Pieces are huge. I have to sit there after somebody breaks it, and I have to keep whacking it with a hammer to get the pieces smaller. When you break it, the pieces are huge chunks because of the weight and the thickness of the glass. So this is the side of the goblet going up from the neck. The neck is right here, and this starts to be the side of the goblet. And so you can see it's extremely thick compared to, where did I just put it? Here's Pyrex. Notice the difference in the thickness in the glass. This is really thick. Pyrex is not so thick. Okay? Same thing when we go to do flat glass. It's only as thick as the pane of glass. The way the goblet is shaped, this is very, very thick. Even if we're looking high up on the goblet, which is here, it's still fairly thick compared to everything else. Okay, so that is crystal. This whole box weighs a lot because there's 2 glasses in there that I've broken. That's why I'm like, I don't really want to break another one for you because I really don't want to, I hate to say it, use that money up out of my own funds. So that is the lead crystal, all broken. Okay, now the next thing that we have to break, which we'll do the after part, right? So we still have to fill in this part up here about after the break. But the way I'm going to break it is we're going to look at it and fill that in, but we're also going to fill in this, and then we're going to fill in that. So in this next break, we're going to address the rest of your data table. So let's see if this works. To expedite our little things, you don't have to watch me tape it. I took a small pane of glass because it's a 1 hit. When we do the next part of the lab, we're going to do 2 hits and we'll do density together, the 2 hits and the density. The 2 hits come from a much bigger pane of glass. When you do 2 or 3 hits, we use this huge glass. This is what goes inside of it. So there's a big difference in size. So we're going to use this little one. I've already taped it. It's hard to see, but there is a piece of cellophane tape right there. I'm going to double wrap this. I have no idea how this is going to work, guys. This is the one that's extremely difficult. Sometimes it works, sometimes it doesn't. Kind of sucks because you use a nail. The nail slips on the plastic. So I cheat sometimes and I try to make a hole with the nail so the nail goes down to the glass and doesn't slip. And the problem is, I'm not, like I said, I keep telling you, I'm not very coordinated. I'm just being honest. It's kind of a joke. I always worry about smashing my hand. Oh, wait, let me see. Yeah, I just check and make sure nobody used these nails. So let's see. I cheat. Safety-wise, I wouldn't let you do this because it's not a good idea, but I also know that if I don't do this, can you see? Let's try this. All right. Wait a second. I'm trying to get it so like you can see what happens once I really break the glass. Maybe that'll work. I try to have the glass at a slight angle on top of the spring steer. I'm going to get back to the 2 holes I made. And 1 hit. I should just use a pair of pliers to hold it. Maybe I'll do that because I've really been very clumsy lately. You guys are probably laughing, but it's true. You can ask Mr. Cool. Let's take my hand away from where I'm hitting. I don't know if this is a good idea or not though, guys, because a lot of times your eye-hand coordination is based on the fact that you know where you're holding it. And it went in. Yay, finally, but no radial crack. Bugger. I mean, no concentric cracks. Oh, I got one tiny concentric crack. And I'll show you what I mean. So, right there is my concentric crack. This is another thing. These rooms siphon for lighting. Okay, I don't know, I gotta get the lighting just right so you can kind of see. There's a concentric crack right here. Everything else is radial. Now, I'm going to take this out. I have to be careful that I don't slice myself when you go, oh, here's another concentric crack right there. So we might be able to look at the concentric crack. I feel like I'm like a circus in a clown show where everything's falling. I'm trying to get a light so you guys can see what's going on. It's such a pain. I hope it doesn't ruin this when I plug this in. Please don't ruin this. Turn my light on. Blah. I don't have enough power. Our dock siphon. There we go. Now I got a little bit of light. You won't have to hold it. Okay, so I'm going to take this out. So you can see there's all these little glass shards I got to be really careful of. This is the top part where the nail hit in. Okay, so we're going to look at the top, and then we're going to look at the back. And I'm going to get the tape off here. All right. So this is the top. We have some pieces that are along the top, little tiny, tiny, tiny shards of the pieces. It looks like you can see that there's a little chunk that came out of the top, but the hole is smaller on the top than if we flip it around to the back. Look at how big and how these little pieces are so easy to just pop out, and they're coming out this way. So this is in a real jagged hole on the back. The front or the top is smoother. It's a more defined hit hole. Okay. So where I put the force on it, this is very narrow compared to the back. So again, this is the front or the top. If I flip it over to the back, you can see there's like little pieces that really want to just pop out the back. And they're being held together because the tape, there's that piece of tape on the front. So it's not allowing the pieces of glass around it to move. All right, so we have mostly radial cracks. We have a concentric crack right there. Let me see if I can get this into shade. It's so hard for you to see. Okay, so I'm going to see if I can get it. And it's hard too for me, guys, because this is it close up. Right off of here, that's a concentric crack. This is a concentric crack over there. I just see. I don't know if you can see that crack right here. Right this way. Everything else is radial. Right now, I'm try to get this to break apart. And we're going to pull a piece out. Ouch. See how it's sharp and pointy after it breaks? Now we have to look at radial versus concentric. We're going to see how this works. I might have to switch this to the ladybug, but we're going to see if we can get this to work. pull this out. I'm gonna move this over here. Actually, I'm not gonna move over there. I got my light right here. All right. This is the top. So if we look at the side, and I don't know if you guys can see it. I don't think you can. So I hate this. It's not really focused. All right, I think, guys, I'm going to switch over to the ladybug because I think I might be able to get you to see it by the ladybug. It's really hard to see. Hold on a second. Let me use a magnifying glass so you can see it. You can see the lines. See if I can get it so it focuses. So the piece of glass goes this way. Yeah, I don't know if you can see it or not. So when you look at the lines, there's actually lines that go, that curve so that perpendicular, I'll have to draw it for you. I'm gonna have to show you how it goes because I don't think you can see the lines in there. There's these little lines that go this way along that side, and that's the radial side. I have to look back at how I pulled it apart because I need to know which one's the top and which one's the bottom. So let me do this. This is the top. So they go from the top away and perpendicular on the bottom. Right, so these little lines, if we're looking at your notebook, go like that on the radial side. So there's waviness, and the lines go like that. Okay, now on the concentric side, I don't even know if I can see this because it's really, really, really tiny. It goes the other way. So it starts off straight up and down, and then it curves. All right. So that's the first part of the lab. Stay tuned for installment number 2, which is multiple breaks. Once you finish out this page, take a picture of it and upload it. And that's part 1, and it's worth points.